Hi, so this will be our VHDL code for our vending machine. Okay, to start off, we always start with library. Okay, second of all, the entity. So our inputs will be the clock. We set 20 cent and 50 cent. And the outputs will be we have two segments for this. And the output, which is Q, is the LED. Okay, so this will be our architecture. Because we are using states, so type state type. Okay, so to begin, if we set equals to 1, yeah, okay, so because there's no coins to put in, display will show 90, which will be 90 on the board, which is in our demo. Because there's no coins put in, it won't decrease. Then output will be 0. So to start off, yeah, so this is the usual one, the no coins put in, display will be 9. Okay, so here it shows that 20 cent equals to 1. So when 20 cent is inserted, display will be 7, because 90 cent minus 20 cent equals to 70 cents. Yeah, so on and so forth. Okay, so this is the first pattern, because if let's say the user puts in 20 cent first, then second of all they put 50 cent, then the display will be 40 cents, because 70 minus 50 cents is 40 cents. Yeah, this is the first pattern. The second pattern will be when 0, yeah. So this is when display equals to 70 cents. When it's 20 cents now, so it displays 70 cents. Then we'll put in another 20 cents. We'll show 50 cents. Then another 50 cents will show 20 cents. Yeah. So when 40 cents is inserted first, the display will show 50 cents, because 90 cents minus 40 cents equals to 50 cents. And then after that, another 20 cents is put in, will show 30 cents. And yeah, so on and so forth. This will be my teammate Samuel will continue from here.
Okay, so hi, my name is Samuel, and I'll explain from the state 50 part. Okay, so when it's at state 50, it will just show that it is state. You'll show that it's the state 50, and it'll just be 40 cents. And then, so how this code works is when it's at the first, whichever state it's starting from, it will always reset the state here. And what it does is that it will always ensure that you are able to either input a 20 cents or 50 cents. And if you want to put a 20 cents in, the 50 cents state will be input into a 20 cent state to show 20 cents on the counter, because our project is using a countdown counter instead of a count up. So in this case, at state 50, you'll be displaying 40 cents left. If we were to put the 20 cents in here, as you can see this line, what it does is it will accept the 20 cents and it will just put in it will just count down the counter to state 70. At state 70, it'll be showing it at 20 cents left on the counter. If we want to put in a 50 cents, it will be this state here. And what happens is it will show 0 on the counter because we have exceeded 90, state 90. 50 plus 50 cents is $1, so that, and we don't want to show $1 because our maximum is 90 cents input. So from there, it will straight away go to 90 cents here, state 90, and on the 7 segment display, it will show 0. Okay, next will be 60 cents. So actually all these states are the same. It's just that we will always use a when here. And what this does is it will always reset the counter for 20 cents or 50 cents according to this line. And it will display the appropriate display on the 7 segment according to the state here. And it always follows with two else if statements. These two else if statements one will be for a single input of 20 cents here, and then the other one will be a single input of 50 cents here. So what it does is it will continue so on and so forth all the way down until we reach the last state at state 90. So what happens at state 90 is it will show state 90, the counter will show 0, and what it does is it will reset and go back to state 0 here. What this does is it resets the counter back to 90 cents so that the vending machine application can be restarted and be used again. And similarly, here in all the previous codes above, what I've highlighted here is the LED signal. What it does is it simulates the open mechanism that the question has given us. So at 1, it shows that the coffee has not been released yet. The coffee has been released already. So what it does is it will switch off the LED when Q is 1. At Q is 0, it shows that the LED is still on, signifying that the open mechanism hasn't been opened yet and coffee hasn't been delivered. So what happens here, the last state here, is that at Q, the LED will be back on, and then the whole system restarts itself. And then here we just have our AND case, and if, and process, and AND architecture. Thank you.
Okay, over here we have our block diagram. So you see here we have our input clock and reset 20 cent and 50 cent input for our vending machine. So when 20 cent is placed in, it will minus 20 cent and we'll be left with 70 cent and so on and so forth. And same thing for the 50 cents. So when reset is toggle, it will go back to 0 after it reaches 90 cents. For our 7 segment 1, there are 4 outputs because 1001 is equivalent to 9. A, B, C, D, E, F, G is our 7 segment output. And for 7 segment 2, we have our 2 outputs because we only need 0 for the 7 segment 2. And same for the output of 7 segment. D3 and D2, they are connected to ground because they are not needed. Like that.
So this is what is inside our 7 segment diagram. So first we will use our library IEE, and then we will use our standard logic to declare it, and then we'll start our entity. So we'll start our port and we'll declare our inputs and our outputs. So our inputs are D3, D2, D1 and D0, and our outputs are A, B, C, D, E, F, G to correspond with the LED that is supposed to light up on the display board. So when we declare our signal input, our standard logic vector bit is 3 down to 0 because we need at least 4 bits to display up to 9. And our output will be 6 down to 0 because of our A, B, C, D, E, F, G that corresponds together with the LED that is on the board. So this shows that. So when our input, we'll declare our inputs and our outputs. So for our outputs, they are an active low. So we input a 0 for the LED to light up. So when there is no 0, the LED, when it's a 1, the LED will not light up. So when our inputs are all 0, it will display 0. So all of the LED will light up except for G. So when the input is 1, only B and C of the LED will light up to display 1. So and so on and so forth, and it repeats for both of our 7 segment display diagram.
So hi, this is the vector waveform that we have simulated. Right here at the highlighted part is our clock. Our clock has been set to 5 nanoseconds interval. Here's our reset. And this reset up here, you see this one value here, is just to simulate a reset in the vending machine that we have designed. And then following that, the reset is switched off so that we are able to input the coins. Highlighted here is the 20 cents. We didn't use the 20 cents in this simulation, so that it'll be easier to show the simulation of our vending machine. Here's the 50 cent. As you can see, we've inputted two 50 cents into the simulation. One's here and another one here at the cursors. Following that, what you see, and here's the highlighted one, is our first 7 segment display. It first displays a 9, followed by a 40, a 4, and then once it hits the next 50 cent input, it has put in a 0. And the second one here, 7 segment 2, it will always show a constant of 0 because we are only counting in tens. The lastly is Q. Q is our LED to mimic the open mechanism that is required in this project. As you can see, the open mechanism is off all the way. Although it shows that it's 0 here, but it's actually an active low. So when you see the demo, the LED light will always be on until it hits an active high, where there is given when the adequate amount of money is inserted into the coin sensor and the 7 segment displays 0, and that's when the LED will switch off, which means here in the simulation it shows is an active high, and after it reset here, as you can see here, it's a 101, which means that it's been reset to 90 cents. And because it has been resetted here, as you can see, in conjunction, the LED switches back on to show that it's ready for the next dispense. Thank you.
So that is our state diagram for our vending machine question. So it starts off with state 0. So when you insert in a 20 cents, it will cycle to this state, and from this state on, we can insert another 20 cents, which will go to state 40. And so when you reach state 40, you can either choose to insert another 20 cents or 50 cents. So if you choose to insert a 50 cents, it will go to state 90, and a drinks will dispense, and immediately it will reset back to state 0. So at state 40, if you choose to put in 20 cents, it will go on to state 60. And if you put in 20 cents after that, it will go to state 80. And 20 cents after that, it will go to state 90. And when state 90, a drinks will dispense, and it will go back to state 0 to reset. So at state 0, if you choose to put in a 50 cents, immediately it will go to state 50. So at state 50, you can either choose to put in another 50 cents or 20 cents. So if you choose to put in another 50 cents, it will go to state 90, and the drinks will dispense. And once the drink dispense, it will go back to state 0 for a reset. So here is state 50. If you put in a 20 cents, it will go on to state 70. And if you put in another 20 cents, it will go on to state 90. So at state 90, a drink will dispense. And once the drink dispense, it will go back to state 0 to reset.